This brain starter brings up an old vocab term of end behavior, and it asks what's the end behavior of the graph below. So in case you forgot about end behavior, it's basically what happens to the graph as x approaches negative infinity and as x approaches positive infinity. So if we look towards negative infinity, you'll see that this graph, as it goes further and further to the right, appears to be approaching y equals 0. So this gets close to y equals 0. And then, from the right side, follow the graph again this way, it also appears to be getting closer and closer to y equals 0, but never truly touching it. So actually, what we were doing with the end behavior was really looking at a limit as the x value approached both negative and positive infinity. And that just tells you what happens at the far left of your graph and the far right. And that's the limits we're going to be finding today. So here, the limit as x approaches positive infinity. Basically, all that's asking is what happens to your graph at the far, far right. The end behavior on the positive axis. Now, for the limit as x approaches negative infinity, that's basically looking at what's the end behavior far, far down the left. And we would just read these things as the limit of f of x as x approaches infinity. And then whatever the number is. In this case, both of these were 0 for this function here, because they both approach the asymptote at y equals 0. So for both of these problems, we're just going to find the limit as f of x approaches negative and positive infinity. Basically the end behavior on the left and the end behavior on the right. So for the function on the left, let's first look at negative infinity. What happens on the far left? Far left, you can see that it appears to be approaching the asymptote of y equals 2. So we would just say that the limit is 2. Now, I know that it doesn't actually touch 2, but it gets closer and closer and closer as you go towards infinity, so that's why the limit would be 2. On the right side, the graph appears to be doing the same thing. So the limit again is just 2. Now over here, this f of x, we have some interesting things happening. So on the far left, you'll see that it keeps going back and forth, but it keeps going back and forth right around the x-axis, or y equals 0. So in this case, on the left, the limit as x approaches negative infinity is 0. Now, we look at what happens on positive infinity, and you'll see that this thing just keeps going up and down, up and down, up and down. That's what's called oscillating behavior, because it goes back and forth. So in this case, the limit actually, because you can't tell, is it negative, is it positive, what number is it heading towards? The limit on the right, as x approaches positive infinity, doesn't exist because it keeps oscillating between really high values and really low negative values.